Hello. Decided to take the Great Math Adventure on the road today. I'm here at the lower falls of the Soda Falls. I'm going to go ahead and shoot your math video here. Just wanted to give you guys a different look of background scenery as we go through. Today's lesson is on multi-step equations. We're going to take what we did yesterday and we're going to do it pretty much the same thing, but instead of just doing one step at a time, we're going to go into doing it 2 or 3 steps at a time and doing a little bit more complicated problems. Alright, let's go ahead and jump in. Alright, just to go ahead and go over our learning target for today, it is that I can solve multi-step equations. So we're going to have some steps to solving multi-step equations that we're going to be following. They won't all apply for today's lesson, but one of them in particular will carry over tomorrow. But just so that they're already going ahead and getting ingrained in your memory and your mind, we'll go ahead and go over all 4 of them. The first one is to distribute. Anytime we have a number that we're multiplying through a set of parentheses, we're going to want to go ahead and distribute that number first. After we're done with doing all the distribution, sometimes you might have to distribute once, sometimes you might have to do it 2 or 3 times, sometimes you won't have to do it at all. But whenever all that is wrapped up, you're going to combine like terms. You're going to put together all the terms that match up. You would put any x's together and any constants together. I know when we were doing combining like terms in Unit 1, we did some stuff with x squared and x cubed. Since these are linear equations, we're going to focus on just expressions that have x's instead of x squareds or x to the cube. So really the 2 that you're going to be focusing on are combining your x's and combining your constants. Now number 3 we won't have to do today in today's problems. We're going to focus on this tomorrow. But what we would want to do is go ahead and get variables on the same side of the equation. What you'll find is we're going to have some equations tomorrow where we have an x on the left side and an x on the right side. And before we can solve those, then we need to get them onto the same side of the equation before we proceed. Our last step is to isolate the variable by using inverse operations. That's just like we were solving in the first lesson. We were looking at what was being done and doing the opposite. If we were multiplying, to undo it we divided. If we were trying to undo division, we multiplied. For addition, we subtracted, and for subtraction, we would add. So go ahead and make sure you have those 4 steps down in your notes. And then after that, that's really all the notes per se that we have today. We're going to just go ahead and do some examples together to go ahead and get you started. Alright, so jumping into the examples, we have example number 1. We're asked to solve for n. We're given 6 equals 1 minus 2n plus 5. So if we go back for just a second and look at our steps, the first thing we want to do is distribute. And since I'm using the pen, it's not going to show me again, but distribute. Now I'll go ahead and click those through. We didn't have anything to distribute, so let's go ahead and combine like terms. So in this, on our like terms, the 6 is over here by itself. We can't move it over yet, but we can go ahead and combine the constants on this side. Now we don't have any other n's, so that's going to stay the same. So on the left, I'm going to keep 6 equals. Alright, I don't have any more n, so I'm still going to have negative 2n. But when I combine a 1 and a 5 together, I'm going to get 6. Alright, now this is going to look like one of those 2-step problems that you were working with yesterday. We need to get the n by itself, so we have to get rid of everything attached to it. If we are looking at what's happening to this n, we are adding 6 and multiplying by negative 2. Remember, we worked through the order of operations backwards, so we want to do the undoing, the adding, the 6 first. So our inverse operation for addition is subtraction. So we want to subtract from both sides a 6. Remember, we do this to both sides so that we balance out the equation. Alright, so on the left we have 6 minus 6. Now normally we would just say that cancels, but if you notice, that's the only thing we have on the left side. So we need to be a little bit more specific mathematically. The reason it cancels in previous problems is 6 minus 6 is actually 0. And normally, we've just been using that as a placeholder. There's been some other stuff over there that we can still leave, so we still have something on that side of the equation. But since that's the only thing on our side of the equation, we want to make sure that we go ahead and put that 0, since 6 minus 6 is 0. And just to demonstrate this a little bit clearer, we still have the negative 2n. On this side, we have 6 minus 6, which is 0. Now, technically, we would have plus 0 over here. But we have something else here that we're adding to 0. And when we add 0 to the negative 2n, it's not going to change anything because of that addition identity property. So that's why we're writing it on the left, but you normally wouldn't write it on the right here because there's already something here. Now we have to undo that multiplication. To undo multiplication, we're going to divide. Now we want to make sure we match our signs. If we're multiplying by a negative 2, we want to make sure we're dividing by a negative 2. We do 0 divided by negative 2, which is going to be 0 because 0 divided by anything is 0. And we're going to be left with n over here. So n is equal to 0. We could double check this by plugging it back into our equation. Negative 2 times 0 is 0. So this would really be 1 minus 0 plus 5. 1 minus 0 would be 1. 1 plus 5 would be 6, which is what the equation is. So we know that we can know that our answer is correct in this and be confident in our answer. So go ahead and take a moment, pause the video if you need to, work through that problem and the examples. If you couldn't keep up when I was walking through it, feel free to rewind and replay. And now let's look at example 2. Example 2, we're asked to solve for x. So notice our first step is distribute. This time we are going to have something to distribute. We need to take that negative 4 and distribute it to both parts of the parentheses. Now make sure that we include that sign when we're distributing, otherwise we might end up with a sign error. So the left side is going to stay the same, 12 equals. Now we multiply through. A negative 4 times a negative 6 is going to be a positive 24x. And I am writing sloppy there, so let me erase that. But it is going to give us a positive 24x because a negative times a negative is a positive. And because a negative times a negative is a positive, the negative 4 times negative 3 is also going to be a positive 12. So again, now we're down to a two-step equation like you were used to seeing yesterday. Again, we want to undo that addition first because we need to go in the opposite direction of our GEMS protocol. So we're going to subtract 12 from both sides. And coincidentally, this does give us a 0 on the left side at all. I promise you that our multi-step equations won't all give you a 0 on one side of the equation. But we get 0 equals 24x. Alright. Again, to undo that multiplication, we have to divide. So we divide both sides by 24. 0 divided by 24 is 0. 24 divided by 24 is 1, but 1x is just x. So we have the answer x equals 0. Again, if we plug this back into our equation up top, negative 6 times 0 would be 0. Following the order of operations, we would do the parentheses first. So 0 minus 3 would be negative 3. And that would give us negative 4 times negative 3, which would be a positive 12, just as is indicated on the left side of the equation. Alright, we got two more examples we want to look at. The first one is y plus 1 divided by 2 plus 7 equals 19. Now one thing I want to point out with this fraction bar is we can treat this as sort of a grouping tool. This is a division symbol, but it's also grouping that top portion for us together. It's telling us that that y plus 1 needs to be grouped together. So when we're looking at order of operations and working our way backwards through the order of operations, that's actually going to fall into our grouping category. So even though there's some addition there, we're going to have to undo that last since it's in our grouping. So if it helps, go ahead and put parentheses around the tops. And technically you could put them around the bottom as well of these fractions because that fraction bar groups our numerator and our denominator. It's not going to play a bigger role in the denominator this time because it's just one number down there. But if we're working our way through the operations backwards, looking at the big picture again, the first thing we need to undo is the addition. So we're going to subtract 7 from both sides. Now we're going to leave that y plus 1 over 2 because those are grouped together. Now 7 minus 7 is 0, so that goes away. And 19 minus 7 is 12. See, I told you we wouldn't always get 0 on that side. Now, remember this in addition to our grouping tool, grouping the numerator and the denominator, this is also a division symbol. How do we undo division? That's right, multiplication. So we need to multiply both sides by 2. And this is a place where some people can get thrown off a little bit. Now, If we were multiplying this as a fraction, this would be 2 over 1. Remember, if you from middle school when you're multiplying fractions, if you have a number on the top and the bottom, or when we were doing unit analysis where we had something on top and something on bottom that was the same, we could cancel those out. Because 2 divided by 2 is 1. 2 goes into 2 one time and 2 goes into 2 one time. So that's going to cancel, leaving us with just y plus 1 on the left. But on this side, we have 12 times 2, which would be 24. Now, the part that throws people off is a lot of times you'll see people want to multiply that 2 through, and instead of just canceling the 2, they'll get rid of that 2 on the bottom, but they'll distribute that 2 through the parentheses, which is in effect multiplying times 2 twice in this. That is something we do not want to do. We want to make sure that we're just canceling here and not changing the grouping on top. Now, our last step is to undo the grouping. So inside the grouping is addition, so we need to subtract. So we need to subtract 1 from both sides, and we get that y is equal to 23. All right, last example, we want to solve for k. Now notice this time we're going to have to distribute twice. We have a negative 1 in the first set of parentheses and the negative 6 on the second. So we want to first distribute on both accounts. We want to take negative 1 times 1 and negative 1 times 7k. That's going to give us negative 1 minus 7k. Now we also have to take the negative 6, and we want to make sure we keep that negative sign attached and distribute through the second set of parentheses. So negative 6 times a negative 7 is going to give us a positive 42. And a negative 6 times a negative k is going to give us a positive 6k. And our 36 wasn't distributed by anything, so he's going to stay the same. Now our next step is going to be to combine like terms. Now in this case, notice that we have k's that we have to combine and constants that we have to combine. So we want to combine those separately. Let's go ahead and start with the k's. A negative 7k and a positive 6k is going to be a negative 1k, or a negative k. And a negative 1 and a positive 42 is going to be a positive 41. And this is all still going to equal 36. Again, this reduces it back down to a pretty basic two-step equation. We are going to need to subtract 41 from both sides to undo this addition here. So we get negative 1k is equal to 36 minus 41. Be careful with your signs. Is a negative 5. Now this is going to be where it's important that we kept that negative 1 with the k and didn't forget about it, because if you see a negative 1k, k is still not by itself. It still has that negative 1 attached to it. We're multiplying k times negative 1. So to undo that, we have to divide both sides by a negative 1. So we get k is equal to a negative 5 divided by a negative 1, which is a positive 5. And that will wrap up our examples for today. For the practice, we want you to go ahead and do the odd number problems. We aren't going to have you do the whole set just yet. We want you to start with the odd problems and check those, and then go ahead and move on to the application, the mastery check. If you need some extra practice, that's why we're going to leave the evens there. That if you want some extra practice at home or after you've taken the first mastery check and you're still struggling a little bit, then you can go back and do those even problems. But for right now, just go ahead and focus on those odd problems and then move on to your application, which there will also be a video for, and your mastery check. Alright, as always, let us know what we can do to help you out. Good luck, and good luck with solving these problems.